Geez. Who are you and what do you do?
Yeah, so I'm Dave Biesack, and I'm Chief API Officer at Apiture. Apiture is a software company that provides software as a service for digital online banking for several hundred community banks and credit unions around the United States. So, as our name implies, Apiture API is a big part of what we do. We have a digital banking platform that is API driven, and we provide those APIs to partners to build applications on top of our platform. And some of those partners might be the financial institutions themselves or might be third parties. But we build everything with APIs, and we use OpenAPI 3.1 to define our APIs and then provide those on a developer portal.
Yeah, I'm a big fan, longtime listener. I've known you for many years, and you're one of the few people comes to the conferences and talks about this stuff, shares the stories, but actually goes back and builds it rather than just talks about it. So always love talking to you about what you do. So let's dive in. You said you use OpenAPI 3.1. So
Yep.
What does that mean from a JSON schema perspective for folks?
Sure. So OpenAPI kind of defined its own way of defining schemas originally when it was originally OpenAPI 1.2 and then 2.0, 3.0. With 3.1, they basically adopted the standard for JSON schema using the 2020-12 definition of JSON schema with a vocabulary that defines certain things that fit with an OpenAPI. And that was using the extensibility of JSON schema. So basically what it gives us is to reuse JSON schema as a standard, as an open standard for defining the data models for our API request bodies and response bodies, as well as using schemas for other things too, like query parameters and header parameters, et cetera. What that gives us is a standard way of defining all the data that flows in and out of our APIs, and that's really powerful. So one of the examples that we've done is I had originally written a tool very early on called our OpenAPI model gen, which basically parses through the schemas within an OpenAPI document. And within the document, you describe all your schemas for your request bodies and response bodies, et cetera. And then this model gen tool will create a schema bundle that extracts all those schemas into a single file. And that allows usability to allow tool people and test people to work with the data without having to understand the wider structure of an OpenAPI document. So for example, someone who's writing tools can create test data to test the APIs. And if they create a test request body, they can validate that in line directly by just asking to validate this schema against the schema bundle without having to understand how to pull schema bundles out of an OpenAPI document. So it facilitates understanding how the data is used within our OpenAPI documents without having to understand the complexity of OpenAPI.
Yeah, that's one of the biggest, I would say, hurdles for teams to get over is inline schemas in an OpenAPI, componentizing schemas, but then external references and the reference kind of mayhem that can come with it. And so you're saying that the average developer shouldn't have to wrestle with this.
Exactly. So, one of the great benefits of OpenAPI, especially from the 3.0 standpoint, is this notion of components and the component structure within an OpenAPI document, which allows you to split up a complex API into multiple files to allow for reuse and componentization. So we have a common OpenAPI document that's shared across most of our other APIs. And the common document describes common elements that are reusable across APIs. For example, for our error response objects, we've adopted the application/problem plus JSON description from RFC 9457. And that's a standard way to describe what happens when an error or a problem occurs in an API request. We've defined JSON schemas for our problem response object for those 400 and 500 errors, as well as a reusable just API problem schema. And that goes into our common API. And then when we define specific APIs within the banking domain, for example, for accounts, transfers, transactions, payment batches, ACH, et cetera, all those different APIs that map to specific banking domains all will reuse these common schemas from common, which means designing an API is simpler because you're reusing things instead of having to copy and paste. You can just reference those. But that complexity can be a reach for people who are implementing or using the APIs, for those that are doing testing or development. So we have another tool, which is, we've actually open source, called API Ref Resolver, which will, and there's other different open source tools that do the same thing for bundling an OpenAPI document that's split across multiple documents, merge them into one document such that there are no external references. Everything becomes self-contained within that document. Our tool was written kind of before some of the others showed up, and it was really designed to support this notion of the component model. So it understands that structure. It works for OpenAPI as well as Async API, but it eliminates a lot of that complexity of dealing with our multiple APIs split across lots of different files and stuff. So it gives everybody kind of the built-in or the self freestanding API definition without all these external references. It simplifies a lot of use cases. And so that includes our use of schemas and things like that.
And this is, I mean, you're doing this within pipelines and within the open APIs, but there's opportunities for other distribution and registries and discovery and publishing within that too.
Yeah. So within our pipeline, we build all of our APIs from source. We have a source file that's managed in Git. Then we run several tools that pre-process the source to create the ultimate or the generated open API that's fully resolved and explains everything and embeds other things. We have some open API generation itself. So we augment the API through this pipeline, and it gives us our generated or complete open API definition. And then that's what gets published into our developer portal. It gets published into our internal software repositories for other people to consume. So if the backend team is building the implementation of an API, they can do code generation off of that to build data objects and data transfer objects, et cetera, on the back end, and implement the rest of the API using code that's generated off the OpenAPI source. But again, when they get to that point of generating code off the OpenAPI, they don't have to worry about any of these external refs. Everything is standalone and self-contained, so it makes their job much simpler.
And you generate code, but then you go even further. You generate a release log for the schemas as well.
Yes. So very early on, as part of our kind of evolution planning for our API design, we decided that we would, as well as just providing a release number on the API itself, we also produce a release or a version number on every schema. So we start off with version 1.0.0 of schemas. But as the schema evolves, if we add a new property to the schema, we'll increment the schema version with a minor update. If we just changed some documentation or clarified something, it'll be a patch version update, or we changed an example, et cetera. But if it's a major version change, it'll be or if it's a breaking change, it will be a major version change on that schema. So part of what we do in our code generation and we build our API documentation is we will look at those schema versions, and that gets injected into the title of the schema. So everybody can see the schema versions. And you can also, we publish these schemas along with our API doc. So I can see version 1.1 of this schema versus 1.2 of this schema and see what's changed over time. As we build or add features to our APIs, we also generate a release log, which is it's a YAML file because it's easier for authors and API designers to author things in YAML rather than JSON, but basically it gets parsed into JSON. And then we have a JSON schema that maps or defines the data model for those release notes. So it's a release notes.yaml file for each API. And then there's a JSON schema that we use to validate that data. So when we create a new change for a new feature, and we use standard, Jira tickets and things like that to track our changes and et cetera, we'll create a new entry in our release notes that describes, the Jira ticket or the task ID of what we're working on, with the description of what was changed and the release versions of what has changed. And it will tell us the version changes for the API on the info.version, as well as any version changes on any of the schemas. And we have tooling that tracks dependencies and stuff. So we know that if schema A changed, but schema B has a property based on A, then we'll automatically increment the version number on schema B when schema A changes, et cetera. And then we generate all that into our release notes. And then when someone creates a pull request in Git, the tooling will automatically run schema validation against that release notes file, so that you can only commit a release notes change that conforms to the schema. You can't make a mistake there. And that becomes very useful. And that's a general philosophy that we've adopted as much as we can, to use JSON or YAML data as data that you can process and do things with, instead of having to parse just natural English language. So we want to have structured data for things that we do throughout our pipeline. So for example, when we do SDK generation, we've got an SDK config.json file that we use to configure the SDK generation. And then we have multiple different tools for doing backend SDK generation off of that. So that's a general philosophy. We try to use data wherever we can to configure our pipeline and our tooling, et cetera. And then when that data is naturally structured, we use JSON or YAML as appropriate, then we can do schema validation to ensure that all of our tooling and our pipeline configurations all work together really well.
Nice. And you mentioned in there YAML versus JSON. What's that? Are there rules to the road there? Are there people who are in one camp or the other? How do you govern that?
We try to stick with YAML as much as possible, because we know humans are doing the bulk of the work here. So our OpenAPI documents are authored in YAML source. These release notes that I talked about are written as YAML source, because the bulk of the elements of the release notes are going to be the descriptions of what has changed and why it has changed. Mm-hmm. So we can say, okay, this API, we added this new operation and we added these new schemas, blah, blah, blah. So a lot of that is going to be just free text. And it's really awkward to write that type of stuff in JSON. It's much easier for humans to author things in YAML. But we use just the schema, I guess it's language variant of the tools that convert YAML to JSON. So there's a JS YAML open source tool that does that conversion, and it's got a JSON model, I guess, attached to that. So when we parse the YAML, it sticks to a specific JSON appropriate schema or language variant for that. So we only use those elements of YAML that are really fully compliant with JSON and not any extensions. So typically users, developers, and authors and API designers will stick with YAML. And then tools will simply just convert to JSON if they need to in order to process the data.
Yeah. I've instituted at different companies slight variations, but usually YAML during design time and even build time, and then run time, and so between build and run, there's always a switch to JSON and machines. But man, I've gotten pitchforks and at places where teams are like, I ain't using YAML. I had a guy at F5 Networks who would show up to every workshop and argue with me that JSON and YAML are not the same thing. And I'm like, I know, but you got to work with me here.
Yeah, I mean, they aren't, but then we just say we're going to stick with the subset of YAML that supports the JSON, vocabulary, basically.
Yeah. You don't stop there. Talk to me about extensions and what you do in the context of JSON schema as well there.
Sure. Well, I love that. So I actually spoke at one of the earlier API strategy and practice conferences about the tooling that we've done for using extensions and the extensibility. So when OpenAPI came out, the authors there were very, very prescient about this. They knew that we needed the ability to extend the OpenAPI specification to allow for other use cases and other ways of injecting data into the OpenAPI document, because the OpenAPI document as a JSON or a YAML document is itself data, right? It's structured data, and we can process it. And that's been very valuable for us, because we have a bunch of custom home built extensions, and we have an entire tool that sits on top of our OpenAPI pipeline that, as I mentioned before, reads our source OpenAPI that we author in our IDE and in our editing tools, and it will pre-process that that source file and create an output OpenAPI document, a generated OpenAPI document that is fully embeddable. And so we extend the OpenAPI specification with lots of different capabilities. For example, one of them is when you define a JSON schema and you have like an enumeration, a typed string, and then an enum that has a list of values. And this happens in almost every API, right, where you need to have an enumeration of schemas. So we have like enumeration, for example, within banking, we have enumeration of different types of bank account product types. So it could be a checking account or a savings account or a CD or a money market, and lots of different types. So all those are documented via an enumeration. But within JSON schema, enums are just that. They're just strings. There's no description of what they are and what they mean. And developers can try to put good descriptions, but even if you have a nice, complete, legible, I guess, readable description or name for an enum, the description is lacking. So we have a separate specification extension, Apiture enum, that tells us what is the name of this enumeration. And then there's a labels.yaml file that goes alongside the source code that has a name for each of the enumerations, and then a label, which could be an English language label for that enumeration. So it's not just a simple identifier, but it's a full English language label, and a description of each one. And then our tool will process that, and whenever we see an enumeration, we can read those labels and descriptions from that external file and then inject them into the description for that particular schema. So as opposed to just having just a flat list of just enumeration values, we'll have a list of the enumeration values and then an English language label for each one, and then a fuller description of each one and what that value actually means. And that goes into the OpenAPI document that we generate out of our tools. We have a bunch of other tools that or things that we generate as well. So we have one that handles deprecation. So rather than just saying deprecated true or false, which is what OpenAPI provides, we have Apiture deprecation in order to deprecate a field or a schema, and we have additional metadata about that deprecation. When the deprecation was first introduced, say version 1.3, when that deprecation is going to be removed, say it's going to be removed on version 2.0 because that's a breaking change. So we go from a 1. Version to a 2. Version. And then we'll have a replacement value to say, okay, if possible, replace the use of this particular feature with something else. So we have a deprecation that says it was deprecated starting on a version, will be removed on a certain version, and here's how to replace it. So that gives us a much more richer detail or information about that deprecation and how a developer would use it to update their code to work around that deprecation before it gets removed. So that's a simple schema that goes into our object on each item that gets deprecated, and the tool will generate additional documentation on the description of that operation or that schema to inform the consumer of that information. With each of these types of annotation that we define, this Apiture enum or this Apiture deprecated or a dozen other ones, we also have a JSON schema that describes the data that goes into that particular specification in the document. So as we're processing this source file, if someone mistyped or otherwise had an error in the definition of one of these specifications, we'll just reject that right off the bat. So someone can't get an incorrect value into one of these annotations or extensions within our source file. So we just rely on JSON schema to do that validation, and we provide all the information on how to validate that data and what values are acceptable and what ranges are allowed and things like that. So for example, when you use the deprecation, we'll parse the deprecated since or replace on values to make sure that those are valid semantic version numbers.
I love it. I love it. So there's a lot there to unpack, but just the basics is I wish everyone approached and knew about extensions and then approached them in such a safe and intentional way, because a lot of people I see walk away from OpenAPI going, it doesn't do what I need it to do. And they don't go where you went. Now, my dream is that everyone embraced it like you do and is doing that. And then I could subscribe, or OpenAPI initiative, the technical steering committee could subscribe to events of all the different extensions by namespace out there and use that to inform the roadmap.
Yeah, that would be very nice to have an understanding of what people need and what they're doing. Can help with the guidance for what's going to come out with OpenAPI 3.3 or 3.4 or 4.0 whenever that happens. So it's useful, like what we've done with, say, this enumeration. So we also partner with Speakeasy, which is a vendor, and they provide our SDK generation for our TypeScript SDKs. Their SDK generation handles enumerations as well, but it has a slightly different variation. They use the specification extension to add these descriptions and annotations, but it was trivial for us to convert our annotation into their annotation in order to pass our OpenAPI document modified slightly to do SDK generation. So that's what's nice about these is it's all data driven. There's a simple data model behind what we're storing within the OpenAPI document. We have schema validation to validate it. We know what the structure is, and it's quite easy then to use that to generate tools that process that source and does something reasonable with it, whether it's within code generation or whether it's runtime validation and things like that. So it's very, very powerful.
Yeah. And I'm asking this because I just got off a call where I was talking to a potential customer about how they're using extensions, and they're using it for their MCP generation and kind of that SDK layer for lack of a better phrase. And so one common thing I hear out in the market right now around MCP, but also A2A and others, is OpenAPI is static. We need something more dynamic. But what you just described to me, OpenAPI sounds pretty dynamic to me.
It is. It takes a little bit of work, but it's there, and that's what's nice about it is it's got a defined model. It has a defined extensibility model as well, so people can implement those tools, et cetera, to do various things with it.
Yeah. Biggest challenge. So for me, JSON Schema is the most important API spec out there, even more important than OpenAPI. It's because it's everywhere.
It's ubiquitous. Yep.
It's ubiquitous, but it's the awareness people have of it is pretty low. So do you have any advice for training, education? How do you get, and you've talked a little bit about where the line is, what they should and shouldn't have to wrestle with and know, but what do you talk about when it comes to team education and awareness?
Wow. So there is actually quite a bit of really good documentation on the JSONschema.org page. So there's good introductions and use cases and stuff, but I think it's incumbent upon us as practitioners to go out there and share. So I haven't been able to attend the JSON Schema conferences at API Days, but if you're new to the field, that's a great place to get started and get plugged in to meet some of the people. And you kind of mentioned this at the very beginning, where I've attended conferences and things like that. And that's how I got my start, was plugging into the ecosystem, plugging into the community and meeting people. And what's always been amazing to me is how open and free this community is. People are always available to help answer questions and dive in and do things like what I've done is to write documentation. So that's what I've done with API Design Matters, which is my technical blog where I write about API design. I want to get out there and share that knowledge with others. And that's what's great about this community is there's so many people who do that sharing. So Eric Vilda just posted about how he's reached his 5-year anniversary for his Getting APIs to Work YouTube channel. So that type of sharing is just so prolific in this environment, which is great. So there's a lot of people in the JSON Schema space who are really very helpful. There's a really good community Slack environment that you can get to from the JSONschema.org page. You can jump into that Slack and start asking questions, and you get so many good responses from people. Everybody's really, really willing to help. But the learning content there is really good. And there's a couple other resources around that. Learning JSON Schema is another website that's really good. And that talks about a lot of the nuances and stuff. And I covered some of that in my API Design Matters blog, where I talked about building data models for APIs and understanding the nuances of JSON Schema, like what it really means to use all of and ref and unevaluated properties versus additional properties and stuff, and where one works and where one doesn't work and things like that. There's some nuances and subtleties there. So it's good to know and learn. So you can look at my blog for that, but there's lots of really good content in that learning JSON schema page as well.
Yeah, definitely. I'm going to be talking to Juan here about some of the learning content and weave in some of his stories and the registry pieces, the discovery, and kind of craft something for the release of this. Let me say goodbye real quick, but don't leave. Let's just do it for pretends, and then we'll talk some more here. Well, I appreciate you coming by and sharing with me as always. It's good to see you.
Always fun to talk with you, Ken.
Appreciate it, David. So what I want to do is chop this up. Like I said, make the one podcast, have the social kind of clips, and then I'm doing some API stack pieces. But we're launching in December at API Days, our company Navtico, and then the first couple of the podcasts. And I'll link to write a story and link to your work and what you share. But the JSON schema stuff is fascinating as far as how important and ubiquitous it is, but there's not, other than the core JSON schema, it just doesn't have the same attention and awareness, but it's everywhere. It's fascinating.
It is everywhere, and it's important to learn and understand it and how to use it correctly. It's easy to do it wrong as anything is. And I fear that's what's going to happen, especially with vibe coding and stuff like that. People are going to get some code generation that just, no, that doesn't work. Or it works for the first 10%, 20% case, but it doesn't cover everything it needs to and stuff. So it takes some understanding, but
yeah,
we'll get there.
Yeah, well, it'll take time, but we're building.